Hello. Hi, everyone. So in this session, we're going to be talking about building observable agents with AWS Strands, Amazon Bedrock AgentCore, and Datadog. My name is Kunal Batra. I am a senior technical advocate at Datadog, and I'm joined by Duan Lightfoot over here, who's a senior developer advocate with AWS. Now, quick story, Duan and I actually worked together a couple of years back on the AWS developer relations team. And when I had the opportunity to present this talk, I couldn't think of a better co-presenter. So you guys are in a real treat in this session. So let's get into the agenda and what we're going to be covering today. So the first thing I want to talk about is why observability matters. We're going to talk about it at a high level and then drill down into some of the challenges we see at Datadog when it comes to pushing these agents into production. From there, we're going to transition it to Duan, who's going to walk us through building and deploying these agents with AWS Strands and Bedrock AgentCore. From there, once we have an agent in production, how do we make sure that this agent is running reliably, securely, and efficiently at scale? And so we're going to take a look at the Well-Architected framework, specifically the generative AI lens for some best practices. And then we're going to see how can we operationalize these best practices with Datadog, followed by some key takeaways and resources. So let's get into it. Why does observability matter? And before we start talking about agents, I just want to talk about today's world really quickly. And essentially, modern architectures have caused an explosion in complexity. There's a diversity of technologies in use, multiple clouds, open source frameworks, different SaaS providers. Essentially, each of our stacks is a mosaic of these stitched services. And then compute is also increasing, especially when it comes to ephemeral compute. We have serverless functions that can last only milliseconds. We have containers that can be spun up just for seconds. And on top of this, the rate of change is increasing rapidly. Now, when we add AI agents into the mix, this just multiplies the complexity. Now, agents are compound systems. They have vector stores, models, evals, orchestration. A lot is happening behind the scenes when it comes to agents. And they can operate with real autonomy. Decide when to make the tool calls in an ever-changing environment. And this is exciting, but it's also unpredictable. These agents are essentially non-deterministic, giving it the same inputs. You're never sure what the output is going to be. They're also evolving continuously, not just the models, but also the underlying frameworks. And then accountability becomes shared. So when something goes wrong, is it the model? Is it the framework? Is it the orchestration? Is it the tool call? It gets hard to start troubleshooting these agents. So at Datadog, we've seen a lot of challenges when you start running these agents at scale. The first one is reliability, right? We don't want our agents to hallucinate. We want to make sure that they are operating and with quality and hitting the goal state that they're meant to. We spoke about complexity. This is hard to troubleshoot, right? If something goes wrong, there are a lot of different components when it comes to agents. And now when it comes to cost, every model interaction consumes tokens, right? And if something goes wrong, these costs can get out of scale pretty quickly. And then finally, security and safety. We want to make sure that these agents are running in a secure fashion and we have enforced guardrails. So these are some of the challenges. And then before we go into addressing these challenges, we have Duan who's going to come up and showcase how to build and deploy these agents. And then we can see how we can address some of these challenges. Duan?
Thanks, Kunal. So I started at AWS about 4 years ago. And one of the challenges I faced was the amount of information that I needed to learn to do my role, to get up to speed with AWS, to stay up to date with what's going on in the industry, and the information just kept going and going. So during that time, I had some helpful friends like Kanal to kind of help me get up to speed to AWS. But after about 5 day once, I felt overwhelmed and tried to figure it out. So the question I have is, how do we stay up to date with so much information? How many of you all can relate? All of the changes in the industry, AI, new models every day, a new agency framework, a new approach, something new is happening. And so when I thought about this and how to solve this at AWS, after about my first month, I put my developer hat on and I said, okay, what I could do is take the standard approach. All the resources that I know and access, let me curate this information and create a newsletter that I will send out to myself, send out to my team, and just write code. But the problem with this is that, of course, I could automate getting the feed. I could do some basic keyword search. I could schedule the execution using Lambda and EventBridge. And I could scan and kind of update this, but there's a lot of manual labor. There's also a lot of conditional statements I had to kind of build in. So the problem I ran into over and over is that I didn't have intelligent categorization. There was no context-aware summaries, right? I could use AI, but it had to be based off of the information I provided it, off of my conditional statements. And then priority ranking. What's the most important thing that I need to know about right now that's going to affect me? How do I put that up front? How do I gain actionable insights and adaptive filtering? So we fast forward to January 2023. ChatGPT was announced in November 2022. I spoke at reInvent, came back, heard about it. I was like, let me try this out. I hopped in, started using generative AI. Then I was like, wow, I could summarize blogs. I could write code. It kind of worked, not really, but it kind of worked. But the problem I ran into once I started using the APIs was that the context windows were so small. It wouldn't fit a whole blog. And so what I had to figure out was, how can I take a blog and use AI to extract the information and summarize? So what I had to do was take each chunk of the blog, summarize that chunk, and then once I have all these summaries of the entire blog, concatenate it and create one summary. This is before RAG, right? So come June 2023, we start hearing about RAG. Now everybody wants to take all their data in their companies and start using it, gain knowledgeable insights, and help their teams, right? How many of you, your organization started building chatbots and started leveraging RAG? I think we all tried to figure out how to do this. Now, the end of 2023, 2024 is when we had function calling and tool calling. Now we start hearing about the terms, agents, the excitement, the what if, what's possible. And then we start having agentic frameworks, because once you start building an agent, now that agent needs memory. Now it needs context. Now it needs to call tools and APIs. Now we have MCP. We need authentication, authorization. We need agents to talk to agents. We need agents to talk to tools, machine-to-machine communication. How do we manage that? How do we observe that? How many of you are software developers, architects, network engineers? Okay, one thing I want to call out before I dive into any code is that all of that information is important when you build agents, because at the end of the day, it's still software. You still need compute. You still need databases. You still need storage. You still need OAuth. You need all of these things. And so when you build these applications, this is under the hood what's the most important. And you add intelligence into that. And so when we look at an agentic system, let's actually start from the beginning. You have a workflow, an LLM, large language model, where it accepts an input, a prompt, you generate a response. We can have a human in the loop of the agent, but then from there, you have the agentic components, like the foundation model, the knowledge bases, the guardrails, letting the agent know you should not do that, right? Guarding the inputs and the outputs, the API and the tool call that it needs to cause, the memory for that short-term and long-term conversations, other agents that it needs to communicate with in the workflows. Maybe you want to have a multi-agent system, right? How do you manage this all? And then from there, once you have that system, how do you continuously evaluate it? How do you get the logs, the metrics? How do you test, evaluate it to say how well it's performing? How do you monitor how many tokens is being used to determine if you could use a smaller model, improve your prompts, your system prompts? How do you monitor and evaluate that? And that's what Datadog is going to talk about today. And so once you have all of this, the entire system in place, now we're trying to figure out how can we gain actionable insights so we can optimize our agents. And this is what when you put all of this together, this is what we're building. And if you look at any software application, all of these building blocks are a part of it. And you'll see how we expose that with AgentCore. Now, the agentic framework that I'll be using today is Strands Agents. It's an open source Python and TypeScript SDK that allows you to build an agent in a few lines of code. It's model agnostic. So if you're using OpenAI, great. If you're using Anthropic, great. If you're using Amazon Bedrock, great. All of that is supported. It supports MCP and A2A. If you're using multi-agent, whether it's Swarm or agents as tools, all of that is supported within Strands Agents. Now, we have our agent. There's a problem. Because how do we take that agent from prototype and put it in production? How many of you have agents in production today? A few people. How many of you have agents in a dev environment or running on your laptop? A few people. Right. It works. It works on your laptop. It works in your dev environment. But then you soon realize, how do you get a isolated compute, secure isolated environment to store that agent in a compute runtime that allows you to have isolated sessions, has access to the internet, has security baked in, so you can provide connectivity to the agent either via something like IAM, Cognito, OAuth, or connect to a third-party provider. How do you actually do that, right? And then from there, you need to be able to scale it. It needs memory, short-term and long-term. All of these are challenges. We talked about the security and guardrails that need to be in place, and then governance. Like, how do you provide policy and evaluations for these agents? Doing this in production is not easy. And then if you're starting with a multi-agent solution and you haven't started with observability, that's going to be even harder of a problem to solve if you already have it in place. So if you're building out agents now, the best thing to do is start with an MVP, which is a small use case. And in the beginning, build observability from that point, along with evaluations. So that way, as you scale your agent, you have observability from the beginning, and you can evaluate the performance of your agent. And that's what Kunal is going to talk about here in a moment. Now, we talked about how we are building an agent. Let's talk about actually deploying that agent with AgentCore. Breaking down AgentCore, it has multiple primitives. It is a fully managed service that provides you with runtime, memory, gateway for tools, browser to be able to search the web, and a code interpreter, along with observability, identity, not just so you can access your agent, but also control what the agent can access, machine-to-machine communication. All of that is baked in. And then policy around the tools it can use. I'll quickly go over some of the primitives here. When we look at AgentCore runtime, and I'll go over this further in another slide, but AgentCore runtime supports any framework in any model. Right? So if you're using LangChain, great, or LangGraph. If you're using Crew AI, great. The Cloud Agents SDK or Strands Agents, all of those are supported, or any model as well are supported in the runtime. The thing about this runtime is that it supports workloads up to 8 hours, right? If you're building an agent, often, let's say you're running deep research or some other application, that agent is going to run for 15 minutes. It can run for an hour. You can have a workload that runs for 8 hours. You can do that in runtime. And all of the sessions are secure and isolated. Now, memory. I'm going to show you a slide here on memory, but the cool thing about this is that you need to manage those conversations along with your state of the agent interactions. Memory supports that short-term and long-term memory. And I'll show you the importance of that here in a moment. Going deeper into runtime. In a few lines of code, you could take your agent, if you're building it today, and take that framework and deploy it to AWS in a runtime. You can do that either in a Docker file or upload a zip file. And from there, it goes into ECR, S3 bucket, and then you launch it into the runtime. And so if we look at this in code, we have our agentic framework that we're using. It can be any framework. We import the AgentCore SDK with the Bedrock AgentCore app. We instantiate the app, and then from there we add an entry point. That entry point allows you to invoke this agent. Now, the thing about runtime, something I didn't call out before, you can launch any framework into runtime. Another thing it supports is MCP. So if you're running MCP servers, you can launch those and use those MCP servers inside of runtime. Once you have your code and everything ready to deploy, from there, a few lines of code, you configure the agent, that creates a Docker file, and then you launch that agent into AgentCore. A few lines of code. This is about 4 lines of code, 2 lines or 3 lines inside of your app, and then about 3 lines in the terminal. It also supports infrastructure as code, so if you're already using CDK, you can deploy with CDK as well. Now, here's one of the features I get a lot of questions about, and that's AgentCore memory. Because when you're building your agent, you're going to need to manage those conversations, right? So the chat messages, the system prompt, the user assistant message along with tool calls, and the session state. All of that goes into short-term memory. Now, once you have your short-term memory, you can actually create something called a strategy. And these strategies can be semantic search, user preferences, a summary, episodic, as well as custom strategies. What this means is that we will automatically extract from those short-term messages or the short-term memory and populate the long-term memory. So this way, in a one single session, you can use the short-term memory. But if you go into another session or you have other agents that need to use that long-term memory, you could actually use the retrieve memory records and add that context into the conversation so they can remember things like your name, your birth date, the type of applications you use, and et cetera from that long-term memory. And if you all have questions about this, feel free to see me when we open up for questions. And again, a few lines of code, we're using the AgentCore SDK, and we're creating a memory. Once we create the memory here, we give it a name. But we can also add a strategy here as well. And then from there, a few lines of code, we can start adding events to memory, and that gets populated. Now, before we hop into the demo, here's what our architecture actually looks like at a high level. So we have a Strands agent. This is actually a multi-agent solution. One single Strands agent, that's our orchestrator. If you look at the pink, that's actually going to be our second agent. That's the agent as a tool. That's going to be deep analysis. So when I built this newsletter agent, I gave it several tools, like to look up the current date, to fetch the latest news, the news. Here's the thing about that tool. This is a purpose-built tool. When you build an agent, I like to build agents that are specialized. Give them the tools they need so they can complete the task at hand. I don't give them a whole bunch of tools because an agent can reason and plan and take actions. So why complicate? Why add more to cost? Why give it a longer time to actually reason on what tools to use? I give it the tools it needs. And so also I control what it can actually access. Of course, I can give it access to the entire internet, but it doesn't need to search the whole entire internet. I know the sites I want it to go to. Another thing about this, I have 2 versions. One focuses on the AWS News, but this agent actually has the ability to add URLs to itself, right? And you'll see in the demo how some of the memory features I use to make this agent be able to be more autonomous. From there, we extract links. Yes, I could use the agent to do some regex, but if I know the tools and what needs to happen, why not use my software programming skills and help the agent be more effective and just use the tool and then use code to do everything else, right? And then from there, we publish the newsletter. I have 2 modes here. I have a browse mode, so I can just talk to the agent. Then I have a publish mode. The agent in the system prompt, which is very important, to guide the agent on how you want it to perform, In the browse mode, I talk to the agent, answer questions, and it knows not to publish. But once we get to the point where we want to publish, now the agent will focus on that workflow. So they're two different workflows. And then finally, the agent has the ability to manage his own scheduled events. So I can talk to the agent and tell it to schedule a daily update or some other update, and it can manage itself. So let's actually hop into the demo before we turn it back over to Kanal. All right, so the first thing we're going to log in. We're using Cognito to sign in. The first thing I'm going to ask the agent is, what's the AWS news today? It's going to look up the current time. It's going to fetch the news. Now, notice it has my name. It retrieved that from memory, right? It knows my name because it learned my name. Now it looks up the latest news. Now, I know you may think this is a chat bot, but the thing about this, an agent has some type of input front end. This allows me to talk and train the agent. Right now, I'm telling it to send me a newsletter. So now it's using that publish newsletter workflow. Look up the current time, fetch the news, and now it's going to extract information from all of the resources that it looked up. So for each URL that it's searching, it's extracting information and determining if it needs to use another agent. In this example, it decided not to use the other agent because we didn't need deeper analysis, but the agent is able to reason and determine that. So now it's going to keep extracting, and then it's going to send a newsletter. Now it's publishing, and you can see it published a newsletter. And you can watch this as at the end, it says process the article URLs for memory tracking. I built a custom strategy so we can remember every newsletter we sent. All the URLs have been processed, so that way it can just look up in memory rather than doing a tool call. And I could determine if I'm getting duplicates or not, right? The agent will know not to send a duplicate about a topic. And you can see who's a recipient, and it has a message ID. So this verifies that it's been sent, but we'll hop into my email, and then we'll take a look. So we'll sync my email, and we can see the newsletter being populated. And you can see we had a too long didn't read. That kind of summarized everything that I care about. It learned that, it understands that, and now all of these are ranked in the topics that are important. The cool thing about this, I built this newsletter because I want to know about the topics I care about, but I also want to know about GitHub repos and everything related to that topic. So I sign out, we sign back in, I ask it, when did I send the last newsletter? And notice here, based on my memory, it knows that it sent the newsletter. So all of this, we're in a new session, it has the memory record of the newsletter that it's already sent, along with the message ID. So all of this came from memory across sessions. It was able to maintain that. Now the next question we're going to ask is to actually schedule a newsletter to be sent daily at 6 a.m. Eastern Standard Time. The agent has to look up his ID. It has to look up actually who it is, so it actually enter the ARM when it actually schedules the newsletter. So it has the ability to look up itself, and then it's creating the JSON to schedule the event inside of EventBridge. And notice here, it tells us everything about the memory. We hop in the EventBridge. We can look at the schedules. And you can see the agent was able to schedule itself. And there's the target. You can see the runtime, the actual agent ARM, when this was scheduled. And then it generated its own prompt that will invoke itself. So now this agent will run daily autonomously, and I can log in and check the status of it. Or I can hop into the GenAI Observability with Datadog and observe how this agent is working in production. And we'll assign it back over to you, Kanal, because he's going to talk about GenAI Observability and Strands agents.
Thanks, Duan.
Yep.
So now that we've seen how to build and deploy an agent in production, how do we make sure this is running securely, efficiently, and in a reliable fashion? As we can take a look at for best practices, the AWS Well-Architected framework. So now this is a 200-level session, so I'm just going to give a little bit of a background on the Well-Architected framework, just in case you're not aware. Now, this actually started a year before what's shown on the timeline back in 2011, when AWS noticed that whenever there were certain outages, there were certain customers who were not being affected by these outages. And this led to conversations and building up a series of best practices internally. And then that got distilled into these pillars, which was released externally in 2015. And then a couple of years after that, AWS released something called Lenses, which is essentially the best practices, but for a narrow domain, right? So in this case, we're going to be looking at these for the generative AI domain, which I believe was just released earlier this year. Now, these are the pillars of the well-architected framework. If you're not familiar with this, I highly recommend attending one of the modernization sessions or catching one of those after the event, a wealth of information. And so we're going to take a look at the generative AI lens of each of these pillars. So in that small font on the top right, you can see the pillar and then how this reflects for best practices for building agents, right? So this is for operational excellence, and we want to be able to collect metrics, user feedback, and functional performance data, essentially the metrics, logs, and traces in a platform. We also want to be sure that we can implement guardrails, right? So we want to observe the incoming logs, the inputs and outputs, and make sure there's no policy violations. We want to be able to detect prompt injection, jailbreak attempts, or any sort of PII exposure. We also want to be able to monitor success and latency of API tool calls. And then track cost per workflow, per user, and per model call. And then finally, measure and report inference efficiencies to guide sustainable scaling. So now let's see how we operationalize this with Datadog. Now, before we go into the demo, I just want to showcase how to integrate with Strands in this case. Now, with AWS Strands and Bedrock AgentCore, we get out-of-the-box telemetry, which is really interesting, right? So with a couple of lines of code, you can see that we are setting, right after our import statements, we are setting the ingestion URL where we want AWS Strands to send all the telemetry, right? So these are going to be the metrics, traces, logs, and that's going to come right into Datadog. And so this is a simple Strands agent that's going to send all the telemetry in Datadog, and then from there, we can kind of operationalize those best practices. So now I'm going to switch over to the demo, and then we can kind of see how this works in action. Okay, so I'm on my laptop over here, and this is the Datadog dashboard. I'm not sure if anyone here is familiar with the Datadog dashboard, but on the left-hand side of the screen, on the bottom portion where you see the errors, metrics, logs, these are the primitives, right? So this is what Datadog is ingesting into the platform. Now that middle section over there, these are all the products and features of Datadog. It's gathering insights from those primitives, and then from there, it's going to be able to tell you, give you those insights for your application, infrastructure, database, whatever you're looking at. And then the top panel over here, top portion of that left-hand side panel, are just the most recently used pieces of functionality or things that we've deemed that you might want quick access to. Now, we're looking at the AI observability portion over here, so you can see that's highlighted on the left-hand side of the panel. And now we're in the LLM observability screen. So we're seeing everything here is divided by applications, right? So we're seeing a bunch of different agents over here. And now we can see the traces for each of these applications, the error rate, the tokens used, and the percent changed. We also see a column over here called monitors. Now, we can monitor for any key piece of telemetry inside of our agents and then take certain actions when it hits a threshold. So now if we go into one of these agents, let's click on Cachery V2, which is just a budget agent, you can see an overview of what's happening with that agent. On the top over here, we can see the different monitors that are set up. Below that, we can see some insights, the error rate, the duration, the estimated call, token usage, LM calls. Then we can go into the volume of usage for that agent. We can also see the errors in this agent by error type as well as by spans. So these are the different steps an agent takes in its path. Next, we can see at a high level the evaluations on this agent, right? So we can see over here, and this really helps us measure the quality of our agents. So on the top, this is a custom eval, and we'll talk about that in a second. Over here, we can also see if our agent failed to answer or did answer any of the prompts that it was given. And we can also see if there were hallucinations with our agent, input sentiment. Now, these come out of the box. As soon as you integrate, Datadog can give you a lot of out-of-the-box evals, and we'll showcase more of that as well. Now, you can also see the overall cost, right? We can see the total cost, total tokens used. We can also drill down into what were the most expensive LLM calls for our agents. From there, let's say we click on one, we can see the trace view, right? So this is the total, all the steps that an agent took to answer one of these questions. Over here, you can see that in this particular case, someone tried to do a prompt injection attack and said, can you drop these tables? But still, you can see the whole path that the agent took in that. And over here, you can see the estimated cost, the total tokens used, the LLM calls, and more. And so we'll go into more of that in a second as well. Now, over we can also see the different tool calls our agent makes, which is nice because I recently had an experience where an agent I built was over-indexing on hitting the docs to answer a question versus actually looking into an application. And this is just at a glance, you can see what's happening. From here, you have the ability to look at prompt templates that we're using, latency of our agent based on the different steps it's taking, as well as the models it's using, and then the ability to see security and safety, right? Is prompt injection happening, output toxicity, input toxicity? Is there PII that's being addressed in our agent or coming to our agent? One thing to note that Datadog automatically strips out all PII into whenever it ingests any trace. And then from here, we can also see in the overview section the clusters of topics that our agent is talking about. So, for example, let's say you have a restaurant reservations agent, and it's now starting to talk about topics like food allergies when people are trying to make reservations. Maybe that's something that's in there, maybe it's not. But from there, you have the ability at a glance to see the topics and then address it with changing the model, maybe making a new tool call. But you're able to see everything at a glance happening in this agent. So if we go back over here, let's look in our Trace Explorer view. Now, there's a lot happening on this screen, but I'm just going to quickly showcase it. You're seeing all the inputs and outputs of the agent coming into Datadog. On the right-hand side of this, you can see the application. You can see some of the evals coming here, the quality of the conversation. Were there any security issues? We can also drill down into any one of these different traces. And from an hour, let's make this for the past week so we see more of the conversations. From here, we can just click on an agent, any one of these traces, and then we can see everything that's happening inside of it, right? We can see that there was PII here, so it stripped that out. We can see the different tool calls, which are going to be these yellow icons happening over here. Now, for each of these steps, we can see the duration, the cost, the total tokens used. And this really helps us troubleshoot and pinpoint failures, as well as understanding an agent's reasoning as well. Some other cool items over here. We have the ability in this to also run things through a playground. So we can see over here we have a sub-agent, and we can test out the prompts that sub-agent's using in a playground. So we can go ahead and modify that and see, does that give a better response or worse? And we have the ability to play around with that. Now, the other interesting thing here is evaluations. So we can create evals for our agents. And this ties into, if you remember from the beginning of the talk, one of the challenges, which is quality of our agents. Now, we have a bunch of different evals that come out of the box. Failure to answer, goal completeness, hallucination, input toxicity, output toxicity, are there prompt injections, tool argument correctness. The way this operates is we have an LLM as a judge functionality. You can choose the LLM, and then from there, it will start classifying all of these traces in one of these evals. You also have the ability to create a custom eval of your own. So we see a lot of companies who want to make sure that their agent responds back in the brand voice of their agent. And that's something that you can go ahead and create an eval for over here as well. Now, outside of that, we also have the ability for creating an experiment. So when you are developing your agent, you have the options, obviously, to pick which model you want to use, which prompts you want to use. And then with the experimentation functionality, you can see which one works best for your particular use case. In this case, you can see over here, if I zoom in a little, these are the inputs. So you can have the inputs of different models, inputs of the different prompts. And then from here, you can see the outputs, which are going to be the information accuracy, user satisfaction, brand voice consistency, duration, error rate, token cost. Now, what we recommend at Datadog is you want to choose the most capable model first, create some sort of performance baseline, and then from there, you can go ahead and experiment with different models, different prompts, and then see how that is affecting your performance baseline with whatever you're measuring over here. So let's go back to the PowerPoint presentation. Now, some key takeaways here. The first is troubleshooting, right? So you have the ability to look at all of the steps agent takes in its reasoning path with that trace view of that agent, right? And each of those steps we can call it spans, and then you can see the overall cost, duration, anything there to help you really pinpoint any failures or if anything that you want to optimize. You have the ability to monitor any key piece of telemetry for your agent, right? As soon as it hits a certain threshold, then from there you have the ability to be alerted for that or automate some sort of action or workflow to remediate that. We have evals as well. So a bunch of out-of-the-box evals that work with an LLM as a judge functionality. You also have the ability to create a custom eval too. Now, we want to make sure that each of the inputs and outputs that our agent takes is monitored. We don't want any data leakage. We don't want any PII exposure. And we want to make sure that we limit the amount of prompt injections coming in. So this really helps you with that as well. For the experiments like we just showcased, you have the ability to change the different models, change the prompts, and then see how that affects certain pieces of outputs. And then just really quickly, I think I just forgot to show something, so let me just switch back to the demo. If we go back to the traces, we can create a data set for our experiment. So we can just choose in real life all the different traces that we just saw, and we can add that to a data set to use to experiment on. And that concludes our talk. And so Juan and I put together some resources, source code, documentation, anything you might need and find valuable from this talk. We wanted to put it on a separate site. And so I'm going to leave that up. And then if there are any questions, feel free to ask. Thank you, everyone, for coming.